Let's do this problem from your lab assignment from section 4.7. It says here that we have a 4,800 cubic or square centimeters of material available to make a box. The base has to be square and the top is open, so we don't count the top, and we want to find the largest possible volume for the box. Alright, so do we understand the problem? That's our first step. The next step is to see if we can draw some diagrams. Well, there's a box involved, and the box has a square bottom, so if we want to include a box with a square bottom, we can label the bottom of the box to be X and X, and the height is not necessarily conforming with the base of the box, so it could be H, a totally different variable. And we want to constrain it to have 4,800 square centimeters of area. Whoops. And so what we want to do is we want to account for each side of the box that has an area. So if we open up the box, we can open up the box and kind of have it look like this. So this is the bottom of the box, the X times X. That's the square bottom. And then we have four sides for the sides of the box, and there's no top, so we don't have to do a top. Okay, so I think those are good variables to start with, a couple of good figures to start with. And now we should try to identify the function that we're going to maximize, and we're going to maximize the volume. So what's the volume of the box? The volume is going to be base times width times height, or base times length times height. The height is H in the base, and is going to be the square in the bottom, so it's actually just X squared times the height. So here is our, if we just call X the base. So I think here they call it B squared, so we can just say this is B times B, and then so this is B squared times H, and so this is their volume that they have. The surface area is given by this, and so the area is going to be 4,800 or 4,800. And then what does that account for? That accounts for the base, which we'll call B from now on. And then there's 1, 2, 3, 4 of these sides, so that's going to be 4. And so this, by the way, I'd like to think about this as the constraint, and the constraint is this expression, 4,800 is equal to let's make this into an equation. 4,800 is equal to B squared plus 4, and then BH. So now that we have that, we're going to solve for this constraint. We're going to take a look at this constraint, and then we're going to solve for H, because what we want to do is we want to put it back into the V formula so that it doesn't have any H's. And so by solving for H here and replacing the H in the volume, then we're going to get our value. So if we solve for H here, we're going to get, so let's bring everything to this side. We're going to subtract by B squared. So this is 4,800 minus B squared. And then we're going to divide by 4b. So that's going to be our expression, 4,800 minus b squared divided by 4b. Okay, so now that we have that, we're going to put this back into our volume formula. So our function now is going to be is going to be this expression, but instead of h, we're going to replace it with this h that we just found. So this is going to equal to b squared times this expression. And and what we could do is we could take this b and cancel it with one of the b's down here. So if we do that, we're going to get just a regular b here, and then this b is gone. And then we can take this 4 out if we wanted to, and just divide it out here. So what do we have left on the inside? It's 4800 minus b squared. And then if we distribute this, the 4 and the 4800 would cancel out, and that will give us 1200. And then we can multiply the b as well. So this is going to give us a 1200b, and then we'll multiply this b squared with this b, or the b with the b squared, and then we're going to get b cubed, and then we have a denominator of 4. So that's b cubed divided by 4. Okay. By doing this, we get a v formula that looks a little bit nicer and easier to deal with. So 1200b minus, we could take a look at that as 1/4 b cubed. And now we have a function of b, or a function of one variable. So the next thing to do is to take the derivative of this, and then find the maximum of v by taking the derivative, finding a critical point, etc. So the derivative of this thing is going to be the derivative of something times b is just that something, and then here the 3 goes down and it becomes a 2, and then we can just multiply this by a 3. So we're going to have 1200 constant minus 3/4 times b squared. So now that we have the derivative, we're going to set this equal to 0. And we're going to solve for b squared. So if we solve for this, we're going to set this equal to 0. We're going to bring this over to the other side, and that's going to give us a negative 1200. And then we're going to multiply by a negative and a negative. And then, so that's going to be a positive, and then we're going to multiply. We're going to have b squared is equal to 1200 times the reciprocal of 3/4 is 4/3. And so this will cancel the 3. The 3 can cancel, and then let's actually get rid of it. And then we're going to get 400 here, and then that's going to be 1600. And then that's going to give us our b is equal to technically a plus or a minus, but of course we're not going to be dealing with minuses, so I think that's just going to be 40. So b is going to equal to 40. So after doing a little bit of work, we found the base that's going to give us a maximum value. And so the next thing to do is we want to find the actual volume. Technically, we should check to make sure that 40 is going to be the maximum area, or the side that's going to give us the maximum volume. So we could do like the first derivative test, or even the second derivative test. So if we think about doing the second derivative test, we take the derivative of this thing. This thing's going to give us the 1200 will be gone, and then this will give us 3/2 or something like that. But it's a negative. That's the important part. Negative 3/2, and that's going to give us a graph that's concave down. and so that's going to be a maximum. All right, so for the last part, they want us to figure out what happens when we put B in, or put 400 in for B, or 40, sorry. And so this is just some calculations to figure this out. So let's take out our calculator. So our calculator, we want to figure out what 1200 times 40 minus 1/4. So let's put a parentheses. There's no parentheses. Here it goes. 1 divided by 4, close parentheses, and then we want to multiply that by 40 to the third power, and we get 32,000. So this is the actual volume, and that's going to be given in centimeters. So remember, the B was the side of the square in the bottom that gives us the maximum, and the actual maximum value is 32,000. Okay, so of course it's always good to look at this from a graphical point of view as well. All right, our graphing program, we want to graph this function over here. V of B is equal to 1200B minus 1/4 B cubed. Of course, graphing programs want to use the regular x and y relationship, so we'll use y is equal to 1200 x minus 1/4 times x to the third power. And if I look at that with the regular window, the default window from -10 to 10, -10 to 10 in the x and y axis, I don't see anything. I kind of see this line over here. That might be part of the graph, but that's not very helpful. But what I do need to know is that my x value goes to at least 40, and my y value goes all the way up to 32,000. So I want to adjust my window here. I don't really need negative numbers, so I'll just start from x is equal to 0 to 40. Maybe I'll go to 80 just to double that. And if I take a quick look, let me take a quick look here. I see at 0 and at around a little bit before 70, it looks like I hit the axis over here. So now let's adjust the y-axis to go from, again, I don't need any negative numbers, so let's just go from 0 to, and this is 3,200, so let's go 32,000, so let's go 33,000 maybe, and maybe 4,000 even. So that's a nicer picture that we can see. And if we trace this a little bit, if we take a look at this tracer and we stop at any time over here, this tells me that when my my base is 23.6 centimeters, then my volume is going to be 25,033. So we know that the volume can get larger, and then it's actually going to hit this top over here. This most programs mark your maximums and minimums for us already, so they marked it as 40. That's 40 centimeters for the base, or for the side of the bottom of the box, and then the total volume is going to be 32,000. Okay, all right, so hope that helps.